Hi all, in this video I am going to explain about stack based CPU organization, that is how the stack can be implemented within the CPU of a computer system. So in a digital computer system, the stack can be implemented in two different ways, that is memory stack and the second one is the register stack. So in this video I am going to explain about register stack. So before we are going to explain regarding this register stack, we have to get an idea about the stack organization. So stack is basically a data arrangement structure in which the last item which is added into the stack is the first item to be removed. So from this diagram, it is clearly understood that the books or the racks are arranged one by one and the last item is added in the top of the stack and the item which is removed from this list is the top of the item. So we can say that stack is working on the principle of LIFO. LIFO stands for last in, first out. So the computers which use stack-based CPU organization are based on a data structure called stack. So the stack is a storage device and that stores the information in such a manner that the item stored last is the first item to be removed. So the data is arranged in the stack manner. And every activities, that is the data is storing and also the processing, and after processing the final results, everything is actually stored in the stack. And it uses the access method LIFO, last in, first out. That is the last item which is added in the stack is the first item to be removed. So in a digital computer, the stack can be implemented in two different ways. The first one is the register stack, the second one is the memory stack. In this video, I will explain about the register stack. So a stack can be organized as a collection of finite number of registers. It is known as register stack. We all know the importance of registers in the CPU. So registers are basically high speed storage locations. So at a particular point of time, whatever data the CPU is processing, the temporary results and the corresponding data as well as the programs are stored in the register. So the registers played an important role in the computer system and the registers are arranged in a stack manner that is known as register stack. So the most important register which is associated with stack organization is the stack pointer. So stack pointer is a register. It is used to store the address of the topmost element of the stack. That means in the stack organization, the data is added, the last item which is added in the stack is the first item to be removed. So it is very important to have an idea about the top of the element which is stored on the stack. So stack pointer plays an important role in the CPU, that is in the stack organized CPU system. So in this organization, every operations as well as the data is stored in the stack. That is the operands or the data is stored in the stack and the arithmetic or logical operations are performed on the stack data, and after performing the operations, the final result is also stored in the stack. So everything is happening in the stack structure. Stack operations. So there are basically two types of operations which are performed in a stack. So one is the item which is adding into the stack, that is known as push operation. So the process of or the operation to insert an item into the stack is known as push. And the other one is removing or retrieving an item from the stack. So that process or the operation to retrieve an item from the stack is known as pop operation. So these are the two major operations normally performed in a stack. So now we are moving on to this register stack. So register stack means the registers inside the computer systems are arranged in the stack structure. So here consider an example. Here we are taking a 64 word stack. 64 word stack. That means the major components of this diagram of this register stack includes the 64 word stack, and there are 4 registers: full register, empty register, stack pointer and the data register. And from this diagram, it is clearly understood that the data or the datas are arranged and the register address is actually moving from the bottom and it is arranged in the increasing order. That is, it starts with 0 and then 1, 2, 3, etc. So the item is added at the first location, that is 1, and after that a new item is coming, it is added in the second location, and after that which item is adding, that is on the third location. So the items are arranged in the increasing order and in the top to top. And about these registers, full and empty, these are 1-bit registers. So 1-bit registers are basically used to store two values, either 1 or 0. And these registers are basically used to identify or to check whether the stack is empty or the stack is full. It's very important because we have to perform certain operations on the stack. That is, sometimes we have to add data into the stack, or sometimes we have to remove or retrieve data from the stack. So whatever operations we are performing, we have to know whether the stack is full. Suppose if you are adding an item into the stack, then we have to ensure whether the stack is full. And also if you are removing an item from the stack, then we have to ensure whether the stack is empty or not. For that purpose, we are using these two registers, full and empty. Stack pointer is actually the register which points to the topmost element in the stack. So in this diagram, the stack pointer points to C, that is in the third memory location. And we have another register, data register. Data register is used to store the data. That is, whatever item or whatever data we have to enter into the stack, or that is added in the data register. Or whatever data or whatever item we are retrieving or removing from the stack, that is also stored in the data register. So this is an overall idea about this register stack, and here we are taking an example of the 64-word stack. So in a 64-word stack, the stack pointer contains 6 bits because 64 is equal to 2 raised to 6. So that's why the 6 bits. And the full register and the empty register, both are 1-bit registers, and it can store either the values 1 or 0. The 1-bit register full is set to 1 if the stack is full. That is, the value of the full is 1, that indicates that the stack is full. And another is the empty register, and it is set to 1 when the stack is empty. So the value of the empty register is 1, it indicates that the stack is empty. The data register which holds the data to be read from or written into the stack. So these are the various registers mainly using in the register stack. So next we have to know the operations performed in the register stack. So basically there are two operations are there, as I mentioned earlier, that is the push operation and the pop operation. So how the push operation is performed in a register stack. So basically the process of adding a new item or inserting a new data element into the stack is known as push operation. So push operation, for performing the push operation, we have to check certain conditions. That is, the first thing we have to check is whether the stack is full or not. So how we can ensure that the stack is full or not? For that purpose, we are using the 1-bit register full. So the value of the full register is 1. It indicates that the stack is full. Then we cannot add an element into the stack. After checking whether the stack is full or not, if the stack is not full, then the next step is to increment the stack pointer, because the stack pointer points to the topmost element in the stack. So we have to add an item into the stack. We have to increment the stack pointer. And after incrementing the stack pointer, we have to take the data from the data register and we can place it into the memory address of that particular stack pointer. So it involves checks whether the stack is full, and if it is full, it produces an error and exit, and the stack is not full, the stack pointer is incremented and the value from the data register is added into the stack. So here we can write like this: SP gives SP plus 1, that is, this value of the stack pointer is incremented by 1 and the data from the data register is transferred to the memory address of the stack pointer. The next is the pop operations in the register stack. So as I mentioned earlier, removing an item or removing an element from the stack is known as pop operation. So performing this pop operation, we have to check certain conditions. That is, the first thing we have to check is whether the stack is empty or not. If the stack is empty, we cannot remove an item from the stack. So first thing we have to do is we have to check whether the stack is empty or not. So how we can do that? So for that purpose, we are using the register, the 1-bit register empty. So we have to check the value of the empty register. And the value of the empty register is 1. It indicates that the stack is empty. So if the stack is empty, it produces an error and exit from this. And if the stack is not empty, that means we can remove item from the stack. So the first step is we have to take the data which is stored in the stack pointer to the data register. That is, we have to shift or move, or we can say that retrieve the data from the stack pointer to the data register. And after that, the value of the stack pointer has to be decremented. So these are the steps. The first, it checks whether the stack is empty, and if the stack is empty, it produces an error and exit. And if the stack is not empty, the data element from the stack pointing the top is removed from the stack and the SP is decremented. And it is right like this. The memory address of the stack pointer is shifted to data register and the stack pointer will be decremented. That is, SP gives SP minus 1. So in this way, we can perform the push operation. That is, we can remove an item from the stack. So next is the advantages of the stack organization. So basically the stack based CPU organization is used for performing complex arithmetic expressions. And also the execution of instructions is fast because the operand data are stored in consecutive memory locations. That is, in the stack, we all know the items are arranged in the consecutive memory location. That is, one by one. So we can easily perform the operations. That is, so the execution of the instructions will be very fast. And another advantage is the length of the instruction is short as they do not have the address field. So if the stack based CPU organization, all these instructions have, there is no need of the address field. That means the zero address instructions are basically used in the stack organization. For example, push operation and pop operation. So there is no need of the address field. So these are the advantages of the stack based CPU organization. In this video, we explained about the stack organization and how the registers are arranged in the stack and the various operations performed in the register stack. Thank you.